Good morning, everyone. While others join, let's quickly recap on what we have seen in the previous session. In the previous session, we started off with the calculation views, which is one of the widely used modeling artifacts in SAP HANA. We got to know why calculation views are important and how they make the application code simpler. In a traditional approach, the complex logic was taken care by the application code, whereas much of the database logic is now being pushed back and modeled in the database, where we will apply variety of operations and conditions such as filters, joins, aggregations, and any new calculations that we want to do. We also saw how this modeling approach enables reuse of models and modularization. And obviously the advanced data processing capabilities that includes the text analysis, spatial analysis, and predictive analytics are included as part of this modeling in SAP HANA. Then we quickly saw the evolution of information views. Basically, what objects in XS Classic have now been transformed into either calculation views or table functions or analytical privileges. Predominantly, much of the information views from XS Classic have been transformed into calculation views only. And in calculation views, we have three types of calculation views. Basically, the data category of the calculation view that sets the property, and we have cube, dimension, and SQL access only. And to quickly summarize the difference between cube and a dimension is a non-aggregated model, whereas a cube is an aggregate model that contains measure, and measures are not allowed in dimension. We moved on to create a dimension calculation view. So in the system demo, we created a material master table, and we also have the data for it maintained. And using the material master table, we did create a calculation view of type dimension. And there we noticed a variety of options, like we went through the semantic layer. What are all the options available in the semantic? Basically, the properties of the calculation view as well we saw. And we also had a quick glimpse on the projection node, which is the node that is attached to semantics in dimension. And in the projection node, we did add, let me maybe quickly show you that view. I'm already logged into my SAP Web IDE on the remote desktop. So we created CV_MATMD, stands for Material Master Data. And we have added the Material Master table to it as a data source in the projection node. And in the projection node, we did the mapping out of all the columns available from the data source. We selected the columns that we want. We are yet to see other things like calculated columns, parameters, and so on. But all the 7 columns that was exposed from the projection node was then available in the semantics, which is eventually exposed outside the calculation view. In today's session, we would like to move on to calculation view of type cube. So as we saw, cube has an aggregation behavior and it needs minimum of 1 measure to be successfully activated. And you have two types of cubes. One is the cube with star join and without the star join. And we will see the without star join first. And one of the important property of cube is that cube can be a calculation view of type cube can be exposed outside HANA DB, and that cube can be consumed in a reporting tool or even in SQL within the DB Explorer or outside HANA as well. Okay, so basically the cube is used to define a data model containing attributes and measures that will enable you to flexibly slice and dice the measures based on the dimensions that you want to select. Let's create this cube. Let me see if the base table is ready for it. So we have PO header, which we are going to use as a base table for the cube. And let me quickly give you a glimpse of the table for people who are not part of the last few minutes of Friday's training. So this data file has been shared with you as well, also on the chat and the email. So we are looking at a purchase order header. A purchase order is a document that you would create relevant to your vendor or supplier when you want to make a purchase of some raw materials or semi-finished goods and so on. Based on the items that you have purchased, the general procedure, if you take a manufacturing industry, is that, and then the production planning happens, and along with the actual production, post which we will be trying to sell the finished goods to our customers. So this is a quick sample. I would say a handful of sample columns from production order table in S4 HANA. Please note that the standard table for PO header is EKKO. Uh, Technical name for the standard table is EKKO, and these are some of the handful of fields that are important from a production order perspective. The first column you have client or MANDT, which is basically the S4 HANA client. And ideally, whenever we have client, we should be using client as a primary key, and also making sure that it is used in the joining condition everywhere. And there are also options to set in the calculation view to make the calculation view client aware in the properties of the semantic node. That also we saw in the previous session, where you can hardcode a client and the calculation view does the filtration automatically, or you can also that's a fixed value of client, and or you can also set the client to session client so that it takes the session client of the user and filters for that client. And then we have the purchase document ID. This is the document ID, the primary key that uniquely identifies each row in this table. We have the purchase order date, the date on which the document was created, company code, document type, and then we have vendor ID, with from which vendor or supplier are we purchasing this a particular materials from. We have language that could be either related to vendor, and then we have payment terms, which basically tells you what is when are you going to make the payment related to this purchase order. Sometimes it could be payment in advance, it could be pay after 30 days, or pay within 10 days, pay within the same month with a certain amount of discount. So that could be some of the payment terms that you have agreed with the vendor, and you have a contract with them for certain materials. The currency in which the vendor is spending, and the net amount which is added with the tax amount to finally get your gross amount of the purchase order. So that's your purchase order header table. Now we have the table created in our HANA system as well. Let me quickly make sure that we have the data also. I'm going to DB Explorer, and this is the container that we have created from our project. We have the PO header table and the data maintained respectively. So let's move on to create the calculation view. I'm going to create a new folder. Sorry, the new file in the calculation view folder. New calculation view, and I would say CV underscore PO header underscore header. And let's call so the data category is cube. which is what we want to explore. Note that when you select cube only, you have this option of whether to tick if you want it with a star join or not. For now, first we will look at without star join. Okay, so let's note some of the differences between the dimension view and this. As you can see, when you created a calculation view of dimension, by default, you got one projection node at the top, which is connected to the semantic. Whereas if you're creating a calculation view of type cube, you get one aggregation node, which is connected to your semantic. And this is always going to be same. You can have any number of nodes and any node, any type of nodes also beneath this in the canvas, but the final node below above semantic, I mean before semantic, should be aggregation only in calculation view of type cube. Similarly, it will be a projection in the dimension calculation view. Okay, so now let's add our data source directly to this aggregation node, similar to what we did for the cube. So I'm going to search for star, PO star. Give me anything that contains PO, and we have the purchase order header table. Okay, so we can see all the columns coming from the header table in our data source. This time let's pick all the columns. So I'm just dragging and dropping the table name into the output column, which automatically does a one-to-one mapping between all the columns input on the output. Also note the infographics here against each of the column. In the dimension view, we only saw attributes, which is represented by a diamond that is filled out in blue color, whereas a measure is represented using a ruler symbol. Okay, so automatically it's trying to detect the dimensions and measures. Later we can set that as well. For example, maybe it has not done the right thing for now. It has detected client and company code also to be measure, which is ideally not, even though they are integers, they are attributes, meaning creating an aggregation type for them does not make sense. You cannot sum up, if you sum up company code or if you sum up client, it does not add any business value and they need to be treated as attributes. We will change that later in the semantic node. Let's look at the properties that it has. For now, we're just going to create it with the default properties and we will look at the nitty-gritties going on. So we have an alias that you can create for this calculation view. And it says you have total number of 12 columns. And if you want, you can also choose which is your client column from your calculation view. So you can choose this client. Okay, so it is saying only if you set the default client, it is useful. It can be removed in which ways. So those are the properties that you have in the aggregation node of a cube, right? Calculated columns you would be seeing today, restricted columns again we'll see today. Input parameters we would cover in the advanced concepts of calculation view possibly tomorrow. And let's move on to the column tab. So in the column tab, as you can see here, you have all the columns coming from your mapping pane, just the columns that you have selected. So here in this case, we have selected all the columns and it is also giving you a aggregation type. So here we don't have the option to change the measure to a dimension. Let's see, let's at least minimum set the aggregation type to none. For client, that is automatically changing it into an attribute. That's great. So we want the client to be treated as uh, attribute. Similarly, company code treated as an attribute. It has changed to attribute. And the keep flag, we will see what keep flag means. But for now, moving on, let's look at the measures. So we have three measures: the net amount, the tax amount, and the gross amount. And they are appropriately set as sum because the aggregation type for amount would, I mean, at least in a general scenario, would be sum if you are looking to aggregate the data. The data types also seem fine coming from the table directly. And as I told you, something else, other things that we can do within the output columns is if you want, you can rename each of the column if required so that you have a different name from the table. And you can also apply filters in the filter expression. So maybe here, let's apply a simple filter. In our case, let's use one of the column that we have. So let's say maybe we want data only for where company code equal to 1000. And so basically here you can use a variety of in the filter to create the filter expression. You can use a variety of things like if any columns that you have selected in this aggregation node can be used. Along with it, if you have created any calculated columns, those calculated columns can also be used in the filter condition. Input parameters can also be used. And then you have the complete list of standard functions that we have, same as in SQL. So you can also have calculations done using functions and operators within the aggregate filter expression. And by default, the language is SQL. You want it to be processed in the SQL engine. If you want, you can force to process it in the column engine of SAP HANA. So you click on validate on the top right corner, which basically checks the syntax of the filter condition that you're writing and see if the expression is valid. So that's the last one we have, the filter condition. We are yet to cover these three. Let's go one step above to the semantic node. So in the semantic node hierarchies, again, hierarchies and parameters we would cover in the advanced concepts. We have the same columns coming in from the bottom. Here as well, you have another option to mark each column either as an attribute or a measure. You can do that, and you have other things like rename the column or show me the lineage from which table each column is coming from as well. And you can also set the semantic, which is similar to data type for a column, but it has more I would say semantic information into it. For example, the semantic for currency is just data type for currency is just a varchar, right? But we have a semantic type specifically for current currencies with a 3-digit identifier. So we can say amount, this is not amount with currency code, so we can say currency code, right? But what is the useful of this? We will see here. This I wanted to cover in the previous session also. How we can do it. So now, since that you have set this column, which is giving you currency, just the currency field as currency. Now what you can do is you can also set the other amount measures as amount. So we would say amount with currency code. Now it is asking you which is your currency code, right? So let's see, it's our ERP. I would ideally like to append the currency code in this. Okay, and this is. Yeah, so here you're saying the display currency is either fixed or column, meaning is it asking you for this amount, is the currency of this amount fixed, like is it like only USD or only you are coming from this table? Then you can put fixed and you can simply choose any of the currencies available here, or you can also type in your currency. I hope, yes, you can also type in your currency. But in our case, the currency is not fixed. As we see in the table, currency is changing for each purchase order. So what we need to do, we need to select a column that is going to give us the currency value. So we're saying column is the display currency, and it will let us choose which column is the currency here. And we are going to say currency. And later it is also asking for conversion tables, which we can later define. We will come to currency conversions once again in the advanced concepts. For now, we will say just OK. OK, so now this net amount column is set as amount with currency. The other columns, let's not set for now the semantics. Let's hope to see some difference since we have set the semantic for the net amount column. So I am saving this calculation view. and I would go on to build this. Okay, it says build completed successfully, meaning the calculation view now should be available in the column views. See here. So we can see the PO header calculation view created. Click on it to look at the calculation view, which schema. You can see all the columns coming out of it. So there are a couple of ways that you can data preview a calculation view. Then you get, yeah, you can either right click on the file that you have created in the repository as well, which is your design time repository, and you can simply say data preview, or you can also search for the runtime object that we have in the data, HDI container like I did, and you can say open data or data preview here as well. Let's do a data preview. Okay, so now you see by default it has opened the analysis pane for us. Let's quickly look at the raw data. So everything is fine, perfect. So you can see the raw data, and note one thing here, that this is the use of setting semantics. One simple example you can see here. Since we have set the net amount semantics as amount with the currency code, and we have also mentioned the currency code is coming from this column, automatically the number that was there in the amount is suffixed with the currency column from currency code from the different column, right? And if you will see the data type of net amount, it is still only decimal and it is not becoming varchar. So what it is doing is it is identifying that it is a currency and it is displaying this. It is still in the, it is maintaining it still in the decimal format, while also appending your currency column just in the display perspective. Okay, so how this is helpful? If instead of doing this, if you had manually concatenated this and this, the data type of this column would become nvarchar, and you cannot apply any aggregation on top of it. It won't be treated as measure. Now the net amount is a measure on which you can do sum, min, max, and any aggregation, and still you will have currencies coming up along with it. And such currency columns is not coming for the tax and the gross amount, where we have not changed the semantics. So there are different types of semantics, like we saw in the drop down. You can choose currency amount with currency code, or you can also say quantity with unit of measure. That also is possible. And you can mark other columns like date columns as the date, and so on. This is basically the type of semantic. It's relevant to very relevant close to, if you somebody asks you what is semantic, if it is semantic layer or a semantic type, it is very close to data type, but it is a more sophisticated data signature for each of your column. Okay, so that's with respect to calculation views of type cube. We have successfully built one, also see the data preview of it, and we see also that the filter that we have set in the filter node is working perfectly fine. Only com code 1000 is coming up. The semantic that we set is also working fine. We saw. And any doubts here, guys, before we move on to the next one? Feel free to ask even your conceptual understandings of measure and dimension. And if anybody is trying out while I show this on the screen, you can even ask me if your deployment errors, if you're getting any.
So I have one doubt. I'm getting one error while creating the table PO header. So can I share my
Okay,
screen? If you,
please go ahead.
yeah, I think I missed any of these steps, I guess. Okay, so I have You can see my
Yes, we can
screen.
see. Yes.
So here I've created this table.
Okay, perfect. So it is under
HDB
DB.
table extension is also there, and then training HANA I've mentioned,
Okay,
and all these
namespace is correct.
characteristics.
Perfect.
And when
And it is
I'm
giving
going,
one error on the table itself. Okay, let's
yeah. So I have to do
once.
this, right? Build selected
Yes,
file.
yes, yes.
Save and build. Okay. So it's started, and so
Okay, so
I'm
let's
getting
expand
this.
this. Yeah, yeah, that's the general one. I most often
Mhm.
than not, I also every time we build, let's keep be mindful of the logs that we get, right? So that we are
Mhm.
used to the screens a lot, and we will try to identify the error messages from the logs. So expand the logs a bit above the terminal screen. Yes, yes. And now you can see from the top, let's come from the top when it has started building, and you would see log messages coming up from, yes, here, right? I think this is good enough. So where it has start, where you say start, right? So the build has
Okay.
started. If you keep going down, I will collect it. Just looking at the files, it's saying out of it has two folders, it has three, it has detected two folders, three files, and keep going
Mhm.
down. And so it has identified the right container. Target service is mentioning, so that is where container name is also mentioned there. Your schema name is mentioning.
But I guess this is not correct container, because if I see the container here, it's I have given this training underscore. I think I'm not.
This is just the display name that you have given here while adding it. Okay. Uh,
Okay.
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 So the service name is above. There are two things. One is a service name, another is a schema name. It's called little up. There is a service name, auto-generated service name here. Uh, just a bit more up. That says X. I keep going up a little bit. Sorry. Yes, XSA web ID hyphen the first one, target service, very first line, right? You have
Okay.
target service. So that is your service name. It has picked
Uh,
an auto-generated name because we didn't mention service name in the YAML file. So service name number one, each service corresponds to one HDI container, and inside one HDI container, you will have one master schema which contains all your artifacts. There will be other schemas which contain system related objects, but the objects that we build will go into the master schema. And the master schema
hmm.
name is training underscore HANA underscore HDA underscore DB underscore one. That we have mentioned in our YAML file. So if you go to YAML file, you will have see that mentioned under schema, right? So that is something we configured. Let's keep going down. Yeah, feel
Okay.
free to check it. Feel free to check it out. Yes, in the YAML file also it will be there. It will quickly open your, so this is your graphical interface, graphical editor, and check under, I think, resources. Yeah, code editor is better.
Code
Keep,
editor.
keep
Okay.
going down. Yes, no, you have not mentioned this scheme.
This is, I guess I missed. Maybe.
But still
Okay.
it took training HANA HDA DB1. That's not somewhere. Maybe you mentioned while creating the project in the UI. That is also possible. Okay, anyways, let's move on with the
Mm-hmm.
deployment error. Let's going
Okay.
down. And it is trying to deploy the table. If you clearly see, it is trying to synchronize the three files it identified. Two of it is hidden file, and the last one is the PO header.htb table. So now it's going to parse the syntax and deploy that. Let's keep going down. No modified files, zero deleted files, one added file, which is your table. And now it is saying, yeah, fine. And it's preparing for deployment. Let's keep going down. And you should definitely see an error message. Well, so calculating dependencies, yes, it says error. So you see after compiling, you see an error
Mm-hmm.
message. Now you have the actual error message. At the end of every execution, you'll only see a simple generic message saying build failed. You will have to go
Mm.
through this build logs to identify what your error message is. It is saying it has not been prefixed with the right namespace, which is exactly right. Because for you, the namespace
Okay.
is, I think, can you scroll right? It is also telling you what is the right namespace that you have to prefix with. So the training is cap sensitive, right? So your namespace, your project name is training only with a capital T, whereas in the namespace, you're giving all caps. That's the only difference. You need to change the training. So
Okay.
it's in which is nothing but the namespace, right? So let's go to PO header once again. If you no, you don't have to change the table name. Let's change the namespace in the PO header.
Okay, got it.
I think this should be fine. Okay, great. Anyway, that's a good question. Something that we didn't cover. So your namespace is cap sensitive.
No, it's fine, I guess.
Yeah, you can do a Control S and build should be fine. Okay, while this builds, anyone else have any other questions? Any other deployment errors from other people? Can we see it has to be prefix? Can you scroll right? Training underscore HANA dot DB tables. You are missing an S with table. Yes, that's all. Because your folder name is also tables.
Tables. Okay. Fine.
Yeah, I'm sure this should work fine.
Okay.
Perfect.
Fine. It's done. Yeah. Thank you. Thank you so much.
Thank you, Apurva, for asking your doubt as well. Anyone else, guys, before I move on to the next topic? Any deployment errors? Any doubts in understanding? Okay, I take that as a no. Let's move on then. Okay, so cube we have covered. We saw that a minimum of one measure is required if you don't set anything as a measure, right? So we saw the type, attribute, and measure with the different symbols of icons. So if you don't set anything as a measure, your calculation view will give error upon build saying minimum of one measure is required. In our case, we had 3 measures. We didn't face that. So that's mandatory. Aggregation behavior. Let me quickly show you what is the aggregation behavior. This is important, right? So why did we do this? In fact, what is the difference between this and the dimension view that we created first? So if you data preview our aggregation node, sorry, our cube, which is having the aggregation properties, what you can do is you can not just simply look at the raw data, which is nothing but whatever is coming from the table here, right? You have not really done any aggregation. But what you can also do is, since this supports aggregation, you can select only the measures and the dimensions that you want to your output, and it is going to apply the aggregation that you have set. For example, you can see we have 4 rows coming in with 4 PO IDs, and we have a variety of net amount against each vendor. We have 3 vendors only, 01, 02, 03. And maybe let's look at how much have we spent across each vendor, right? So if you put, let's drag and drop vendor to the x-axis and the 3 amounts to the value axis. Okay, now you can see here, it is automatically taking sum, right? Because 4 rows needs to be now aggregated into 3 rows. And the net amount for each of the vendor needs to be summed up accordingly. So it is automatically doing a sum on all these measures because we have set that aggregation type of these measures to be sum. And this is basically the aggregation behavior, right? In a projection node or in a dimension calculation view, this will not happen. Regardless of how many columns that you pull in, it is always going to show you just the default raw data as it is. So let's maybe data preview that as well. Let's open data on the material master calculation view we created. And if you see here, we have 10 rows and the unique column in this is the material ID, right? The primary key is material ID. So if you remove material ID, ideally you do not need that 10 rows, right? It can be something else. For example, material group. If you simply pull in material group, you will have only these three things. So let's see either the aggregation behavior, how it is working here. So if you pull in simply material group, it is doing a select distinct, right? So it is working how it is going to work on attribute. And here the only kind of it's not really aggregation, the only kind of function that you can apply compared to sum in aggregation is distinct here. So if you select material group, it is giving you only distinct of that material groups. And pulling in anything to the okay, now it is creating some, but I think this is because of the analysis pane. Maybe if you do a select star, let's write a query and see how that also behaves. What have I named the client column as MA and DT? Yes, this is the actual behavior in the analysis pane. Actually, you cannot see that because it's automatically doing aggregation on top of it since it's the analysis pane. That's for our debugging only. If you see here, you're selecting material group and mandate, and it is giving you all the 10 rows by default. Sorry, I think even the distinct will not work by default. So even if you select only the material group, it is giving you all the 10 rows by as it is, right? So this is the difference between this is the difference when you say that the dimension calculation view does not have aggregation behavior, whereas uh, uh, whereas cube calculation view has the aggregation behavior. The same thing, let's do it in the cube. So let's select um, vendor, come on, net amount. Yeah, you see here, I'm not even saying sum of net amount. That's the main thing. I'm not even saying sum of net amount in my select query, but it is automatically taking the sum and giving me the just unique vendors and the sum against each vendor. 4 rows have been now aggregated to 3 rows. I hope this is clear. Let's move on. Okay, so from cube, we are going to look at cube with the star join. So as we have already seen, and you most of you are aware what a star join is. We also saw that in our SQL concept because star join is supported in SQL as well. The cube with the star join is used to define a data set, same like your cube, made up of measures and attributes, but this time by joining multiple dimensions with a central fact table. That's the main difference. So just look at the difference between the cube, the infographic, the pictorial representation of a cube where you have only single fact table, whereas when you have a cube with star join, you have a single fact table that is joined with multiple dimension tables, right? So here they're saying you can combine facts and dimensions. Aggregation behavior holds good, same like your cube, and it needs measure, again, same like your cube. And yes, it can be consumed both by reports and SQL, like we did in DB Explorer. Everything else is same with same as your cube, just that it gives you a star join mode where you can do where you can join fact table with a multiple dimension table. Okay, so let's do this in our, let's try a hands-on of this one. And for this, I would need to create another dimension table, or let's see if we have, okay, we have z-test table. I'm not sure if that is any joining condition valid. Okay, any wishes, even though it does not have a joining condition, we can just define it, right? Um, okay, so let's add that. Let's create a new calculation view again, new, I would say calculation view. And this time I would say CV underscore star join. Okay, the data category is still cube. I am simply ticking the with star join tick checkbox while creating a new calculation view. So now you can see, right? So the difference now, the first when we created data category dimension, the node that was connected to semantics was projection. For cube, it is aggregation. For cube, it's star join. It is star join. Right? Star join is the node that is connected here. As you can see, you don't see a star join node available on the left side. It is you can create star join only if you create cube of type star join. So now it is asking us to add the data source, same like we did in the previous one. So let's add the data source. And this time let's take our central fact table. Our central fact table should contain at least one measure. That's the definition of the fact table. So let's use the pivot header only once again, which has the measures. Okay, pivot header. So the fact table is now added. Yes, fact table is now added. Tech category as cube not allowed. Okay, so it is saying you cannot add cube to this star join. So let's delete that. You see the error message here, red symbol. It says that you cannot add cube inside a cube with a star join. Let's delete that. And let's directly add the table this time then. We chose the CV. Okay, only calculation views are allowed in, yes. So these are the restrictions we should know about, right? So only calculation views are allowed to be added in the star join. And it is asking us calculation. Okay, I think the cube will be added. Let me first select the dimension one. Cube should be added then, right? If you're able to add only calculation view. So let's select the material master first, which is our dimension. This is our CV of material, and this is of type dimension. Okay, no error here. All things have been added. Now we need to add more dimensions to it, more data sources to it, so that we are able to do the join. Now let me see if I'm able to add the fact table. Shouldn't I be able to add a pivot header calculation view? Okay, it's still giving an error. View having data corrective doesn't make sense. Let me quickly see if that is just a warning message or if it is going to give us error. It's still asking me to add data source. Before I do that, let me add an aggregation node now. And to the aggregation node, let's add the PO calculation view once again. So note that I am choosing the CV, not the table. And the aggregation node, now I want to pass it to the star join, and this works fine, right? So this is basically what we should do. So the central table should be passed from below the star join, whereas the dimension tables you add as a data source within the star join. Okay, I hope this is clear, because in the star join you cannot add a calculation view of type cube, and you cannot even add any tables. You can only add calculation views of type dimension in the star join. The central fact table should be coming from below from any layer below the star join and passed on to the star join as a fact table. So in the aggregation node that we have put in, let's select all the columns, and I can even name my node, right? So I can say rename. I right click my node and I say rename. I'm giving this and naming this node as fact table. I think there's a lag. Anyways, okay. So now your fact table is there, represented by the gray color and a different symbol as well. And you have your dimensions represented by the blue color and a different symbol. Now let's add maybe one more dimension, right? You don't have any restriction on the number of dimensions you can have in a star join. So let's add that z-test table that we have. Cannot add a table. It needs to be a calculation view of type dimension. Okay, so in that case, I will need to create a new table, and that calculation view. Any which ways, let me proceed, right? So I hope this is understood for you guys, that you can keep adding more data source to your star join. It still gives you a plus symbol to add more data source, and even after adding the second one, you can add more data source, third one, fourth one, right? That's the purpose of join, where you can define multiple joins together in the same node. So now that my star join column is there, what I need to do is I need to first click on the column from the left table and drag and drop it to the column from the right table. And now if you see, it has created a join from the main.dt column to the client column. And bottom here, I can define my join conditions. We will go to that later when we see joins. Let's not worry about it. So the one join is MADT with client. Another join is the material ID. So we have in the material master material ID. And to be honest, in the viewer header, we don't have it. Okay, we'll go to those use cases in the upcoming thing. But for your high level understanding, anyways, the working is still the same. So we have executed a star join. The details of the join we will see in the join session. Uh, but high level, this is basically a star join, and you have added one or more dimensions to the star join node directly. Restriction number one, the dimension that you're adding to the star join should only be calculation view of type dimension. You cannot add a table. You cannot add calculation view of type cube to the star join. Second, the fact table should be passed on to the star join from other nodes beneath it. It cannot be added directly to the data source. And finally, you define the join condition in the join definition mapping of the star join. And let's see in the final semantics if the columns are coming. So we have 7 columns coming in, and you will see only in a join, only in the calculation view of type cube with star join, you will see two things, private and shared. And you can see in the shared, we are getting all the columns from our dimension table, right? These are all columns from the material ID table. So in the star join, why we don't see any private columns? Maybe because no mapping is done. So let's go to the mapping, all the columns from the central fact table, let's pull it. So now you can look at it in the semantics. So in the private, you are getting all the columns from the fact table, whereas in the shared, you are getting all the columns from the dimension table in the join, in the star join node. So it's not behaving like this, like any other join where all the columns come under private. The dimensions from the multi-dimensional join that you're doing are shared columns in this view. What do they mean by shared? Because they are being consumed. A dimension like that exists outside this view as well, right? Because we have selected calculation view of dimension only. So that dimension columns are being shared with this cube with a star join. That's what it means. Let's identify. So you can see 12,7, 12 private columns, 7 shared columns. Building the star join CV. Okay, perfectly executed fine. Let's quickly data preview to see if there is any difference there because it is a star join. And here you can see actually all the columns, both your shared and private, are coming together in the available attributes and measures. Right, so not much difference here. They are simply available for you to be consumed in the reporting tool or any other calculation views if required. Okay, so the join is done on MANDT column, and you can see the data points coming in. So all the MADT columns were same only, right? So I think we had 4 rows in our material master into 10 rows into PO. We got 40 rows now. Any doubts on the star join wise? Any conceptual understanding that you have as when you compare cube with and without a star join? Okay, I guess not. Let's move on. So we saw 3 categories, right? Let's take one step back. We saw 3 categories in the calculation view of calculation view. Cube, we saw that. Cube with and without star join, we saw. Dimension, we saw. We have created, and the dimension that we created only we have used in the star join cube. And finally, we have something called as SQL only view. So this is nothing. This is not much different from what you have already seen. So let's quickly cover it in the theoretical part. So the SQL view basically stands for, as per definition, the CV with data category SQL access only is not visible to the reporting layer and does not support multi-dimensional reporting. That's very clear, right? So when you say it is not visible to any external reporting, it is only accessible within the HANA, meaning you can access this view in another view, use this view in another view, or use this in the DB Explorer like we did for any ad hoc purposes, but it cannot be consumed by any other reporting tool like SAC or Web Intelligence or even non-SAP tools. And second, they do not support multi-dimensional reporting, right? What is multi-dimensional reporting? Like what we did in a star join, or the same thing can be simulated without a star join as well, where you're joining multiple dimensions with a central fact table, and you can slice and dice the data based on the dimensions and measures that you're selecting. That's multi-dimensional. That is also not possible. The primary intention of these views is to use as data source in other calculation views where you will do multi-dimensional reporting, right? So this is nothing but the same type of view that we have been created in the cube or the dimension, but simply that it cannot be, it is not the one that is going to be exposed outside of HANA, and it is like an intermediate view that you want to create. But why do you want to take all this pain of creating this intermediate view, right? So it can be used in one of the advanced concepts, like when your calculation view is taking a long time to build. Sometimes your calculation views could take a long time to build because and there could be a variety of reasons why it is taking long time to build. And one of the reason could be that you have a very complex hierarchies defined. So far, we have not seen what hierarchies is. Some of you might have a high level understanding, but for now, let's just understand it that in such a scenario where your view is taking long time to build just because of your hierarchies, then what we will do is we will create a calculation view of type SQL access only and remove the hierarchies there. And the hierarchies will be included in the calculation view above that SQL access view. So what it does, so why are we actually removing hierarchy is purely because SQL view does not support hierarchy also. Since it does not support multi-dimensional reporting, it does not support hierarchical reporting also. And so it cannot build hierarchies when you build it. But SQL views takes less time to build since it skips a lot of this technical build processes that is required to expose a view outside HANA view. Right. So this can be considered purely as an intermediate view without technical hierarchies or multidimensional reporting. Simply create some of the logic like calculated columns, filters, or you can even have normal joins without star join, and use that intermediate view in another view which you are finally going to expose. And there you will be creating other advanced concepts like technical hierarchies or input parameters and so on. So that's your SQL view, SQL access only view. You wouldn't see any difference when you create in the graphical editor or anything. You wouldn't see any difference when you create such a type of view. I've also included the reference for this how to avoid the long time of CVs. It's a completely side topic, right? But this reference link has the entire operation of starting with how you will first make sure that view is taking long time to build just because of the technical hierarchies. So it has a series of steps like enabling some logs and looking at your trace files to make sure that how much time is taken in the technical hierarchies build. And finally, if you confirmed that it is because of technical hierarchy, then you can use a CV of type SQL access only to avoid that long time build by removing the hierarchies. Okay. So we have seen all the different types of calculation views that you can create. So get data category covered. 4 types we have seen calculation views. We will again recap tomorrow, maybe if required. And towards the end of today's session, we will have even a hands-on exercise session where we will have a use case that you guys will try out maybe for 10 to 15 minutes, and then I can explain my modeling approach. But as a next topic, we will move on to the different nodes that you can have in a calculation view. So as we have seen in the graphical view editor, on the left pane, we have the variety of nodes that you can drag and drop into the canvas and basically use that node for your modeling purposes. So these are the different types of nodes that you can create. You would see a couple more on top of this as well, like graph or anonymization that falls under very advanced concepts of SAP HANA, graphs and predictive analytics or textual analytics is not part of this training as requested. But these are the ones that you see on the screen are basically the most widely used and basic calculation view nodes that you can have. Starting with, I'm breaking the order here, starting with projection and aggregation node. So we saw that in a dimension view, we had the projection node. We did have a bit of hands-on on it. In the aggregation node, in the cube calculation view, we had the aggregation node connected to the semantics by default. We saw the behavior of aggregation node and the behavior of projection as well by data previewing the dimension view and the cube view. We will cover a bit more in-depth concepts of aggregation view and aggregation node and the projection node first, and then move on to other nodes such as union join that basically combines data from 2 data sources. So if you want to compare this with what we learned in the SQL, imagine that the projection and the aggregation node is more like consuming data from single table. So the basics of SQL that we learned, right, where we simply wrote SQL statement from a single data source. Compare that to join and union or intersect and accept. Things like that take in multiple data source, and it is very synergic to the relational operations that we tried out in SQL by using multiple data sources. We will see each of this node one by one, starting with the projection node. So the projection node is used to filter. The purpose of projection node is used to filter or obtain a subset of the required columns. So this is the main purpose. Either remove some rows by adding some filter or remove some columns by selecting only the required subset that you want in the output. This is the main purpose. And on top of this, you can also have a few things like you can create calculated columns. You can define primary keys in a projection node. And you can also use projection node to remove duplicates and select distinct from the from the input set of records. What are the different data sources that you can have to a projection node? The data source to a projection node can be table, like what we did, or it can be other views. Okay, so that also I think we did in the last cube with star join we created. Both in the aggregation node and the projection node, you can have other calculation views as well. Then you can have table functions. Table functions are nothing but SQL views. Okay, we will see that in the upcoming sessions. They are like similar to procedures or SQL views, and it is just that point to note here is that table functions can be used within projection node. Keep in mind. So now let's look at maybe a projection node and see that the various characteristics that we have explained on the screen, do they hold good? Starting with projection view can have only one input, and it also allows for calculated attributes creation. So we need not waste our time to create new views. We can use the existing dimension view only and see the properties of the projection node here. So we already have a projection node. So as we saw here, what we can do is in the projection node, you can add calculated columns, which is available. More about that in a separate slide. We will do some hands-on for calculated column, but just note that projection node allows you to add calculated columns. And the projection node allows you to add a filter expression as well. Maybe let's do that filter expression this time. Maybe as a simple example, I will use some functions also. So here we have mandate unit of measure created on. Okay, we have a created on. Let's use some function on top of this. So let's say we want to look at only the materials that was created on 2023. Okay, so I'm using the created on column in my expression, filter expression, and I want to extract just the year from it. So I'm going to functions and I'm exploring my date functions. What are all the date functions available? Let me see if extracting years from this, there is a function available. So I see extract year as a function. So let me click on the information button. It says syntax is extract year and then pass a D, which is date format. Purpose finds and returns the value of a specified year from the specified date. Awesome. So this is basically I want. So I click on extract date and I put my column inside that exact date. And this should be equal to 2023. Right, this is the filter condition we want. Let's validate the syntax. Syntax is valid. Saving my calculation view. So first point, you can add only one data source to a projection node. You see, as soon as one data source is added, the plus symbol goes away. You can simply delete this data source if you want and change the data source and add another one if you need it. But point number one, only one data source can be added. Point number two, calculate it allows creation of calculated columns. 3, it is used primarily for filtering. And 4, you can choose a subset of the columns from the available columns that you have. So for example, if you let's say if you don't want to see MANDT as a column, removing that would give an error. Let's say if you don't want a material type as a column, I would say simply remove mapping. It has been removed. Material type I choose. I say remove mapping. Yeah, material type mapping has been removed, but now it is giving me error, asking me to map something else. I can simply click on this and delete. So I don't even want this in the output. Yeah, remove material output. Yeah, so I can also select a subset of the column. I can use a filter expression to filter some rows and I can create calculated columns. These are the primary purpose of projection node. Save it and I'll quickly see if I'll deploy it and quickly see if the filter that I applied is working fine. And before I build, maybe just one more thing. Maybe let's see if we can have distinct. See if we have any properties. Properties of that column. See, you want to keep flag is some filters. Okay. One more thing that you can have is something called as transparent filters. So when you choose on the individual columns, right? So you have something called as transparent filter. Keep flag, we will see transparent filter. You have yes or no. So this is nothing but transparent filter means that if you want to filter the data output using a column, but you don't want that column to be part of the select statement. Right? Let me repeat. So in the data preview, you are not having that column, but you want that column to be used in the where condition to filter the rows that you're getting, right? So that is a transparent filter. The filter is not visible for you in the front end, but it is transparent and being applied in the back end. So you can choose any column to be a transparent filter if you need it. And you can simply say transparent filter true. And that can be used in the filter condition. That can be column can be used in the filter condition as a transparent filter. Okay, so that's transparent filter. And so let's go to the columns. Let's look at this one. Any other options do we have? Okay, that's pretty much it. Let's build a CV. Perfect. The calculation view has been built fine. I will do data preview here only. Let me quickly look at the raw data. No data is coming. Maybe because there is no 2023 date in the material master. Yeah, there's no 2023 date. They're all 1980s, 2001s, and hence you do not see any output. Cool. So that's your projection node. Um, so the next node, so projection node and aggregation node is widely used. And so these are the nodes that we want to fully concentrate on and understand the difference conceptually and also hands-on. Um, so by saying that, let me move on to the aggregation node. And we will always keep going back to the output of the projection and the aggregation node to compare the differences. Okay, so aggregation node. So the aggregation represents a relational group by and aggregate operation. Okay, very simple, as straightforward as that. So an aggregation node represents select statement, and in your projection list, it means that you're going to have an aggregate function, right? Like what we saw in the SQL, sum, min, max, count, average, standard deviation, variance. These are all some of the aggregation functions, and you have relevant aggregation types for them in the calculation view, right? So you have average, count, max, min, and sum as an aggregation type. And finally, you also have an empty aggregation type, which we saw in the hands-on session. For a dimension, we set it as empty. Okay. And the aggregation node simply represents a select statement along with some aggregation on top of your only for your measures. So there is going to be select statement, a list of dimension, a list of measures with aggregation defined like what we saw, And finally, since you are selecting some dimension also in your projection list, there needs to be a group by statement, right? That is mandatory. So group by statement. So that's basically an aggregation node. Again, quickly, let's to compare a projection node and an aggregation node. A projection node is simply a select statement you with a where condition where you can apply some filter, right? So two purpose we saw select statement. You can reduce the number of columns in the projection list, or using the where condition, you can filter the rows. So that's simply a projection node, select, from, and where. Compare that to an aggregation. It has select and in the select, it has aggregation defined. It has from. It can also have where condition, and it finally has group by. Okay. So the commonality between aggregation and projection is one is filtration. You can have filtration in both these nodes. Two is calculated columns. You can have calculated columns in both these nodes. Just that in the projection, it is going to be a calculated attribute because and you can, I mean, no, in general, it is a calculated column. You can keep it like a calculated column itself. But if you're going to create calculated measures, you might as well create that in aggregation node. So both these nodes support filtration and creating calculations. So let's open our existing PO header CV, which has the aggregation node. Okay, so I've selected the aggregation node. Let's look at all the options that we have, starting with mapping. This is, we are clear about the mapping. And in the properties of the mapping, we have something called as keep flag. Keep flag, when you select any one of the column, you have both the transparent filter and the keep flag here as well. Keep flag we will see just in the upcoming slide. Transparent filter we have seen in the projection node. Same is the purpose of the transparent filter here as well. And you can see you also have the filter expression exactly same like you had in the projection node. It allows you for filtration, no restriction. It's all the same. You can choose between functions, operators, and any elements that you have here. And you also have the additional thing that you get along with an aggregation is something called as restricted columns. You would see only calculated columns in the dimension, but whereas you will see both calculated columns and restricted columns in aggregation. Again, let's keep it aside. We will be seeing today itself what a restricted column is while we do the calculation column also. But other than that, pretty much, I think the basic of aggregation node we have understood. Let's to explain a bit more on the aggregation node and the differences, we would be using the group by clause. So these are the differences listed for you on the screen. A projection is used to select data without aggregation. Very clear, no group by clause. You will get the entire data set for the selected columns. Aggregation, group by clause will be used in the aggregation. So you might get less number of rows in the output compared to your data source. And using the aggregation, you might be passing less data to another node. Okay, so using so basically execution time can be faster. It might be faster in an aggregation node since you will be passing less number of data to another node. But obviously you will use aggregation and or projection based on your use case only. And in the semantic layer, you will always get the same output for both aggregation and projection. So only if you data preview at the projection node level or the aggregation node level, you will see the difference. But in the same calculation view, you will get the same output, be it a projection or the aggregation node, because the semantic node acts as an aggregation node, because semantic node has an aggregation behavior inbuilt within it. That's why you can see the aggregation type set at semantic node. For example, what I mean is we can see in the semantic node, if you go here, it's here also you can see the aggregation type, which is being passed on from the bottom. And the same thing is available even for a dimension aggregation type, even though it is set empty because these are all attributes. The semantic node behaves same regardless of which type of calculation view it is. Okay, that being said, I would like to now cover how do we control the aggregation behavior within a node? Okay, and first, for you to understand this, you need to get a basics of a use case where such an control of aggregation behavior will be very much required. Okay, so let's take example. Let's take an example for that. I will be providing the Excel as well, and I need to create the table for that. So for that, we are going to use something called as purchase order line item. First, let's look at this table and understand what this table contains. Then we will create this table in the create this table in the HANA, and then move on to use this in our aggregation node. So as you can see here, the table contains client column, which is starting with the same that we have in our purchase order header. Let's compare this with the purchase order header. We quickly fill out the data here, guys. Give me one moment. Okay, so that's your data. So basically, this is also a table, example that I'm taking, but it is very much relevant to the real world scenario. Purchase order line item is a table that exists in S4 HANA. The standard technical name for a purchase order table is EKPO. Just repeating, the header table is EKKO, and the line item table for purchase order is EKPO. And what this basically contains is the granular level of detail to your purchase order header table. What do you mean by granular level of detail? Maybe one more granular level and one more drill down level of details to your purchase order. Because what you see in your purchase order, you're seeing this is my document. This document has been created on this date, and I want to purchase from this vendor, and this is the amount that I'm going to pay him for my purchase. And you have other details like when I'm going to pay him, which company code, what is the document type, and all that. But what this is missing is what is that you're actually purchasing, right? That information is not there in the header table. What material you are purchasing, what semi-finished goods you are purchasing. That information is there only in your line item table, where you have once again the PO ID, which is the same as the PO ID coming from the header table. Right, you can see the numbers repeating that starts with 46000 ending and goes in the range of 21 to 27, and you can see the same range here. So the purchase order ID is commonality between the line item and the header table, and on top of it you have another primary key in the line item table, which is a line item number. So inside one purchase order, let's look at these two rows only and understand what these two rows means. Inside one purchase order, which is 4600021, you have two line items, meaning you are purchasing two different material in the same purchase order. So assume it's like you are writing your monthly grocery, right? And let's say you'll have a lot of items in your grocery list, and each of this item list, it is basically a line item table will be there. But if you want to look at the summary of your grocery, where it just says on which date you are creating the list and what is the total amount of the list, that is available in your header table. Now, so this is basically the line item number. It says 0102, 01 you are purchasing material 03 and material 01. These are the two materials you are purchasing. And these two materials, there are other details like which company code here as well, and which plant and storage location you want to store this material. It arrives at your location, where you're going to store it, and which plant is going to produce or use this material in the manufacturing process, so on, right? And how many quantity of each material you're purchasing. So I want material 03. I want 5 quantity, and material 01. Sorry, I want 10 tons, right? And this is 5 liter. Here I want 10 ton, and the price for each quantity. Note that here, this price that you see in the purchase order table, at least in this example that I want to show you guys, this is price for each quantity. So 1 liter of material 03 is 250 rupees. Similarly, 1 ton of material 01 is 100.10. Okay, so what will be the overall price then? The overall price will be this into the quantity, right? Simply this into the quantity. So that's the overall price I'm paying for this material. Similarly, I'll take this. So this one, the amount that you are going to calculate from your purchase order line item table for each quantity, how much it is, and then if you multiply and sum it up, it will match with the purchase order header amount, because these are same information, just this is header information, and the line item level is one more granular level of information. Okay, so such thing can be repeated for everything. Let's repeat this completely for all the rows, and you see here, and let's take the sum of the entire purchase order amount. So you can see the sum here is 18544 for 314431, and let's take the sum in our header table as well. I think there is a minor discrepancy. Okay, any which ways, ideally it is supposed to match. So this is the sum. So basically what I want to show you was how to simulate this in an aggregation node, right? Basically, you have done some calculations. You did quantity into price, and then finally you summed it up. Let's try to simulate this in an aggregation node, whatever we did here. Let me quickly create the table here, guys, for this. And something easy that we can do is maybe create an Excel file and let the tool take care of the data type mapping and all that. Let me see if Excel is available. So it's unfortunately maybe not available. Forced to create this table quickly. Okay, so we have the client column that is going to come in for sure. POID is there still. And next to the POID, we have basically our line item ID. Material ID, company code, plant storage location. Line item ID is 3, material ID is 6. Material ID. Code. And storage location. Quantity, unit of measure, price, and currency. I'm having only integer type of quantity, unit of measure. And price and the currency. Sure, let me keep it 10. price followed by the currency. Okay, so our table is ready. And we have an additional primary key here, which is line item. Well, I think we have 11 columns. All yeah, 11 columns. Okay, what is the error? Incorrect syntax near somewhere I missed the braces. There is a command that is missing here. Okay, perfect. Cool. So we have the data in the table as well. Let's create a new one, new cube for this one to understand the keep flag functionality. This is very important, and this is also, it will also seal your understanding of how aggregation node works. So let's call it PUCV underscore. We want a cube without a star join. We simply want to use the aggregation node. So we're using the cube. Okay, close this. Okay, to the aggregation node, we are going to add our line item table. Let's bring all the columns for now. And while we do this, let's also start creating the calculated columns, right? So as in the Excel, we saw we want to do a multiplication of the price into the unit of, sorry, into the quantity, right? So I'm just going to the calculated columns here and I'm clicking on plus. And I say there are two things you can create, either a counter or a calculated column. So for now, let's create a calculated column. And you see CC underscore one is created by default. It will have nvar char as a data type. Let's get into that definition and let's change the calculated column name. So it's a good suggestion to have a prefix that identifies if your column is coming from raw data or calculated column. So I would keep the CC underscore still, and I'm going to call it CC underscore amount. Right, and the amount I want it to be of a decimal 13,2. And now the semantics. So first I have defined the general properties where I'm just mentioning the name, the label and the nodes are not mandatory, and the data type is mandatory. Based on the data type that you select, you will need to either fill the length or the scale and so on. So decimal 13,2 we have created. Now we are opening the second pane in the calculation view, which is semantics. We understand the meaning behind semantics. Now we are going to set the semantics of this calculation column. So do you want this calculated column to be defined, treated as an attribute or a measure, right? Thus it lets you create calculation column of type attribute or calculation column of type measure. So two, both come under calculated column, but either you can create a calculated attribute or a calculated measure. We are going to create a measure since it is amount, right? And as soon as you make it a measure, you need to define the aggregation type. And the aggregation type is nothing but the same that we saw on my PPT screen. These are the different aggregation types that you can have. And for the amount, sum is what that makes sense. Okay. We go back once and we'll come to that. We create a new one. See. Decimal 13.2 semantics. Sure. Okay, I think it is trying to identify the aggregation type on its own. Let's proceed anyways. Sure, aggregation type is grayed out. Tool down is grayed out. And the last option is the expression. Here we are actually writing what is the expression of the calculated column, right? Here is where you're going to define. You can simply open the expression editor, click on this, that opens the same expression editor like you had the filters. So everywhere the expression editor would be same, only you can use the elements, functions on the operators from the left side pane, and you define an expression here and finally click on validate syntax to define the to check if the syntax is valid. So now you're defining a calculated column. So what we wanted to do, we wanted to use two columns for that, right? So we simply want to do, I choose line item table, correct? We simply want to do quantity into price. Why we have, okay, I think did I call it net amount? I think I didn't change the color name anyways. Yeah, it's called. Okay, so the price is the net amount. So the quantity into amount we are doing. So we will get the amount for each material level. Now we will get here, right? Let's click on validate syntax. Hopefully it is correct only. It's perfect. And we can simply go back. Your calculation column is now defined and the syntax is valid. Perfect. As you can see now, there were only 11 columns in the table earlier, right? But now you have 12 columns coming in as output of this aggregation node, because in the end you have the CC underscore as well, and the aggregation type of that is set here to sum. Here also you have a keep flag filter. Let's see, that's the main purpose of this demo. We will be using keep flag first. Let's see the data preview without keep flag. Let's see the data preview and how it is going to work. So I also want to set some things as attributes. These should be attributes, so they should not have any aggregation type. Company code and plant quantity is correct. Net amount is fine. And let me also do this. Why still keep it as net amount? I will rename this to price. Okay, rename to price. Let me quickly check the calculate column if it has affected the dependencies. Price automatically renamed here, and the columns as well. It's coming as price. Perfect. And the client also no aggregation. Okay, so let's save and activate this. We quickly take a look at the semantics. we have all the 12 columns coming in at semantics as well. And here you can see that the CC is a formula, right? That's what it is saying. Let's data preview now, deploy and data preview. Just after this demo and understanding of keep flag, we will take a short break, guys, but please have your attention for this as this is important. Okay, so it is built. Right now, let me data preview this one. Okay, first, let's look at the raw data. Is the price calculated correctly? Yeah, you can see the CC amount 1250101, ending also with 110, same as what we calculated in the Excel, right? So the price is calculated correctly here, which is nothing but, sorry, the amount is calculated correctly, which is price into quantity, right? Now, let's go to the analysis pane. And let's try to see if we are getting the same sum at the price. So in this case, let's say I want to select, I don't want to select at the line item level. I don't want the material ID or the line item. Now I want to just see a summarized view from the line item table. So I'm simply selecting PO ID and let me see if the PO against sum against each PO ID is fine. And here I also have the CC that we have calculated. So I'm just dragging and dropping the CC into this. So for the first PO ID, which is 460021, it is saying 5215 is the sum against this POID 5251.50. But if you see here for this POID, the sum is not 5000, sum is only 2251, which is the same in the header also 2251. But the calculation view is now wrongly calculating us at 5251. Where did this first before we know it is wrong for sure, right? Because in both the data that we have provided, be it the line item or header, we have not provided, but which is ideally supposed to match. There is no number called 5251. So the sum of this is 2251 only. But and even in the raw data, sorry. So even in the raw data of this, even in the raw data, if you see, the sum is 2251 only, but still in the analysis, when you are taking a sum of against each POID, the sum of CC amount is coming wrong. First, let's see how this wrong number is calculated, then we will see how to correct it. Okay, so how this wrong number came, we will see. For that, let's go back to the Excel. So what it is currently doing is, if you look at, so this is our amount column. Now let's calculate something called as total amount, total PO amount, we will say. Right, this is something we actually want to calculate, but how the calculation view currently is now calculating is, so the price it is summing up. So the price, if you see 250 and 100.10, the sum is 250.10. So let's put 350.10. Sorry, 350.10 is the sum of both the prices. And what it is also doing is it is doing a sum of price. It is doing sum of price is, or it is calculating, then it is calculating the sum of quantity. So now it is doing the sum of quantity. So the quantity is 10 plus 5 for this purchase order alone. So it is 15. So now if you if you multiply the sum of price into the sum of quantity, let's see what is the number that we are getting. So this into 15. sorry, into this. This is exactly the number that we are getting in our calculation view, 5251.50. So now I hope you understand how the calculation view arrives at this number. And the only mistake that it is doing is that it is before, basically what it is doing is before doing the calculation, it is aggregating, right? What it has to do is first to do the calculation of the amount price, and then it should aggregate to arrive at the right number of 2251. Rather, it is first aggregating the price and the quantity individually, then it is doing the calculation for the amount, which is clearly giving us a wrong number. And this is exactly where a keep flag is going to be used. Let's go back to the definition of our calculation view. And what you need to do is, note the difference before we go there. Note the difference. The amount is calculated rightly when you are having the CC, when you're having the full data preview. Why? Because the primary key is also selected here. What is the primary key here? Either your material ID or the line item ID. So let's see what happens in this, in the same analysis only. If you drag in the line item ID, as soon as you drag in the line item ID, you see the sum of amount now becomes a right number. 1250 plus 1001. If you add, it is 2251 is the right number. So the only mistake is that the amount should be calculated at line item level and not calculated at PO level. And that is what we should make the calculation you understand. Always calculate the price amount at the line item level, even though if line item is not selected in the output, so that I get the right number. And that is exactly where a keep flag is going to be used. And we are going to go to our semantics. And in our semantics, either you can set the keep flag in the aggregation node also, or in the semantics also. Let's set it in the aggregation node itself so that the right output is passed outside. So we are going to the aggregation node, and at the line item level, we are going to say keep flag. So this is a keep flag column, and I'm simply checking keep flag in the line item. I save. This is the only change I'm making. Note that this is the only change I'm making to our calculation view, and I'm simply building it. Okay, it does build successfully. I'm closing the data preview and starting it once again. Once again, first let's go to the raw data. The numbers look the same. They are calculated the same way, and they are exactly the same number in the raw data. In the analysis, let's drag in the PO ID along with the CC amount that we have now. No, not yet. So I think we need to set the keep flag at the semantic level as well. Let's see if the keep flag is set at the semantic also. So in the aggregation node, we did set the keep flag. So the output is hopefully passed rightly from the aggregation to the semantic. I think now it is still getting wrongly calculated at the semantic once again. So here as well, we have a keep flag button, columns being taken. Let's data preview at the aggregation. So what you can also do is you can also do intermediate data preview whenever you're doing such kind of debugging and analysis. You can also data preview at the intermediate node level. If you right click the calculation view on data preview, it is simply like data previewing on the schematic, like the overall output your data previewing. But what you can also do is you can data preview at the node level. And this time I want to data preview at the aggregation node level and see if how the calculation is coming up. Because I have given the keep flag, I expect it to come up with the right amount. No, it is still not coming up in the keep flag. Is the keep flag set correctly? Keep flag is set correctly here as well in the calculated columns. Let me go once again to the mapping and see if I need to set keep flag here. So line item. I want to keep flag for line item. Okay. Back to my columns. Keep flag is set at the line item level, which is right. Building it. We are also using the same example where we set the keep flag is true at the order ID level. Okay, let's look at that now. Successfully completed. Data preview at the aggregation node level. ID. No, what's happening? Sticking. Okay, let's spend a few more minutes on this debugging. We've clearly set the keep flag multiple places. Line item will be keep flag. Any other keep flag do we have? Label column data masking hidden conversion related attributes converted. Okay, for the columns it's showing unconverted. It's giving error. The data is not correct at the aggregation node level itself. Right, so let's say if we have any more semantics here. So measure that we're calculating correctly. Stable function is right. Columns we have line item and we have selected key flag. Maybe let's select the PO also because it's one step above it, but any which way we can select PO, it's okay, it shouldn't be a problem. Just the line item. The line item, calculate the price at the line item level. Okay, let's give this a last try. If it is not behaving as expected, I will spend some time post the training and I will show this to you just this section once again in tomorrow's session. Okay, no, not yet. Fine. Just excuse me for this one, guys. So I will complete this demo in tomorrow's session, maybe. But I hope you got the concept of a high level. Just to quickly recap before we go on a break. So here you see in this example where the order needs to be calculated, the same example where the price into quantity is going to be our sum, and it needs to be calculated at the order ID level. First, the price and the quantity needs to be multiplied at the order ID level, and then only sum needs to be done, right? So without that, if we are doing first sum of quantity and sum of price and then multiplying both of them, we will arrive at 160, which is the wrong answer, whereas 40 is the right answer. And for that, the only thing that we are doing is in the column output, we are setting our keep flag to be true. which is the order ID level. So we are telling the calculation view when we say keep flag true, what it means is even though if I'm not selecting the order ID in my output, the error comes only, the discrepancy comes only when you're not selecting that primary key in the output, right? So even though I am not selecting order ID in my output, always perform the calculation for these calculated columns at that level and then give me the summation even without the order ID. That's what keep flag means. I'll try to show this to you in the hands-on session in the upcoming session. Any doubts, guys, before we take a short break?